Hello and welcome to the ASC video series. I'm Dr. Sean Perry. This is an Introduction to Statistics, STA 2023. We're looking at a Chapter 2 problem on grouped data, mean, and standard deviation calculation. So here I've copied a problem from the homework in addition to the formula sheet. It says the following table is the frequency distribution for the amount of hours worked per week by 100 IRSC students. So right off the bat, we know this is grouped data because we're looking at intervals of hours worked and a frequency that the 100 students responded to, yes, I do work that number of hours inside of that interval. We also know the answer to the first question. So it asks these population or sample data, and the answer is it's definitely a sample. This is because 100 IRSC students is not all IRSC students. And hence we are talking about a sample taken from the IRSC students. What else are they asking us for down here? They're asking us for mean, variance, and standard deviation. And so we go to our formula sheet to see how to calculate those. Here we have grouped data, and we are looking at a sample, so we use these symbols. Likewise, we have formula here for variance and standard deviation. So we'll begin by looking at the mean. The mean is given as the sum of m times f divided by n. And so we need to go find these symbols. What are their values? N is given as 100 here. The number of people in our sample is 100. F is the frequency. And m is going to be the midpoint of the intervals. So how do you calculate a midpoint? Calling this x1 and x2, that's just their average. x1 plus x2 divided by 2. You could think of this as a good guess for the representative value of this interval. So the first thing I'll do is extend this column to include m. Taking midpoints of this data, so 0 plus 8 divided by 2 is 4, 8 plus 16 is 24, divided by 2 is 12, and so on. You might notice that the midpoints are just up 8 from each other, and that's because the intervals are of length 8. Looking at our formula for the mean, we're going to need to calculate the sum of m times f. So let's create ourselves a column, m times f, to keep track. And in this column, we're just going to put the values m times f. So 18 times 4 would go first. That's 72. From there, we just add them up. That's 1968. And then you can see from the formula, all we have to do now is divide by 100. And that's going to be 19.68. But I'd like to also show you a way that we could get this on the calculator. Here is a graphing calculator, or a good impression of one. And to input these things as a list, we would first open a curly brace, second parentheses, and we put in our m column here. So 4, comma, 12, comma, and so on. And once we're done with that, we press second parens to end it with a curly brace. We store this as second 1, which gives us list 1 here. Pressing enter, we now have this list stored in our calculator. Whenever I say L1, it says, ah yes, you mean those 6 numbers. From here I could do whatever I like with this list. So now we put in L2 in the same way as the frequency list. We close, we store as list 2. Once you have those lists input into the calculator, you can go to sum and then do L1 times L2 to add them all up. And then we divide by n, which was 100. There's also a function in the calculator. Second, over to math, and down to mean. This, to calculate a weighted grouped data kind of mean, we would put L1, comma L2. Some newer calculators are going to have prompts inviting you to put a frequency list in. That's where you would put L2. So now let's come back and look at the next question, standard deviation, so S squared. So we recall the formula for that. That's the sum of m squared f minus the sum of mf squared over n minus 1 for samples. So the only thing we're missing right now is m squared f. If I were doing this by hand, I would absolutely go back and create an m squared f column. For example, 4 squared is 16 times 18 is 288, and so on. Then we could take the sum of that column, get 51,264. After you calculate these things, you can input these directly into the formula. I would write it just this way. Notice my parentheses here in order to isolate the numerator and divide it by n minus 1. Order of operations should take care of everything else. That's 126.6036 and so on. So rounding to 3 decimal places, that's 126.604. From here, we can pretty much directly calculate your standard deviation. It's the square root of the variance. Make sure that you use the unrounded version of the variance and round it to 3 decimal places. We get 11.252. Notice we could have also put this into the calculator using our list operations. Going straight from the formula, I could say that we want the sum of L1 times L2, L1 squared, excuse me, times L2 minus the sum of L1 times L2, then squared, divided by 100, divided by 99. Alternatively, there are preloaded functions in the calculator for that. For example, standard deviation can be calculated the same way that we did mean, putting in the values list, comma, the frequency list. Now, I will say one thing about this, which is that these preloaded formula only work for samples. If you were to use a formula for the population, you would have to correct it. That is to say, it would be slightly off. I'll also say this, though, if you want to get one formula from the other, you really just have to multiply by n minus 1 to get it off the bottom, and then divide by n. That would transform whatever your other standard deviation was into the population standard deviation by canceling the n minus 1 term and replacing it with n as in the population equation. So you could also manipulate the output to get the population standard deviation and variance should you need them. Voila. I hope that helps. And good luck with your studies.